Good day, everyone. Today, we're going to talk about useful products. What have you observed with the slides presented? These are products of electromagnetic waves. Now, what are electromagnetic waves? How many electromagnetic waves can you spot? So these are the different electromagnetic waves. We call it electromagnetic spectrum. Electromagnetic spectrum is the name given to the range of electromagnetic waves when placed in the order of increasing frequency. These are the radio waves, the microwaves, the infrared waves or infrared rays, the visible light, the ultraviolet rays, the X-rays, and the gamma rays. The electromagnetic spectrum is divided into regions, representing the range of energy from low energy to high energy. Low frequency radio waves with long wavelengths up to high energy, high frequency gamma waves with short wavelengths. Are electromagnetic waves dangerous? Look at the wavelengths. The wavelength in the radio wave is greater compared to the wavelength in gamma rays. The shorter the wavelength, the higher the frequency, and the more energy that they carry. So meaning to say, the radio waves has a higher wavelength compared to the gamma rays. Meaning to say that as the wavelength decreases, the energy increases. And as the energy increases, the hazard also increases. How are the electromagnetic waves arranged in the electromagnetic spectrum? They are arranged in a decreasing wavelength. We start with the radio waves, which has the greatest wavelength, then the microwaves, the infrared, the visible light, the UV rays, the X-rays, and the gamma rays, which has the least wavelength and the greatest energy. It's very easy to remember this. We will just remember the following statement: rabbits mambo in very unusual expensive gardens, which equates to the following electromagnetic waves. R stands for radio, M for microwaves, N for infrared, V for visible light, U for UV rays, X for X-rays, G for gamma rays. Again, we would just remember the statement rabbits mambo in very unusual expensive gardens, which are arranged in an increasing frequency and in a decreasing wavelength. Let us now check our understanding. Arrange the electromagnetic waves in the order of wavelength, starting with the longest wavelength. Okay, here it comes. Let's try. Okay, so to start with, we have the radio waves, the microwaves, the infrared waves, the visible light, the ultraviolet rays, the X-rays, and the gamma rays. Next, let's have this one. Arrange the electromagnetic waves in the order of energy, starting with the highest energy. Okay, correct. Let's start with the gamma rays with the highest, followed by the X-rays, the ultraviolet rays, visible light, infrared waves, microwaves, and the lowest, which is the radio waves. How many different electromagnetic waves can you spot? You would see there the radio waves here. The radio waves on the TV screen and the pilot talking on his radio here being transmitted through the aerial on top of the plane's cockpit. You would also see here The microwave, here. In the snack bar to heat up food and being picked up by the radar dish on top of the control tower. You also see here the infrared, the grill in the snack bar heating up food. You also see here the visible light. The visible light here, the light sticks being used to direct the plane. And then the X-rays here, that is used to scan the baggage through security, identifying the dog inside the bag. You also see here the ultraviolet rays, that is used to check the money and other notes. Now, let us identify the low-frequency electromagnetic waves. When we say low-frequency electromagnetic waves, this refers to the following: the radio waves, the microwaves, the infrared, and the visible light. Now, let's try to talk about the radio waves. The radio waves have the lowest frequency, approximately equal to 3 times 10 to the power of 4 to 3 times 10 to the power of 9 Hz. But this has the longest wavelength, approximately 10 to the negative 1 meters to 10 to the positive 4 meters. That is why they are mainly used for communication. Radio waves mostly pass through the body. They are not strongly absorbed and are thought to have less effect on the health of living tissue. How are radio waves produced? Radio waves are produced by passing an oscillating electric current through a long wire called an aerial. The frequency of the radio wave produced is the same as the frequency of the oscillating current. This allows radio waves of different wavelengths to be produced. These radio waves have slightly different properties and are used for different purposes. Can radio waves travel through walls? Radio waves are not absorbed strongly by walls, which is why radio signals can be received indoors. Tall objects like buildings and hills can prevent radio waves traveling directly from a transmitter. But this is not always the case. In some areas, the reflection of waves of other buildings or hills can actually lead to improved radio reception. What causes television inference? Television signals can be subject to inference. Television signals are broadcast using radio waves. Normally, the picture on a television screen is sharp and clear. A second fainter image sometimes appears on the screen beside the main image. This is called ghosting because the faint images look like ghosts. It can occur in hilly or built-up areas. The main image on a television screen comes from signals which travels directly from the transmitter to the area on the house. Signals from the transmitter can also strike tall objects such as hills or buildings. Some waves are reflected back to the house and detected by the TV aerial, causing the ghost image. Reflected signals take longer to reach the house than direct signals. The ghost image information arrives after the main image, and so the ghosting appears beside the main image. Now, what are radio waves used for? Radio waves are used for broadcasting. Radio waves of different frequencies are used to broadcast radio and television. Radio waves are also used for communication. Several types of radio waves are used for communications like Bluetooth and Wi-Fi. Radio waves are also used for radio control. It sends signals to control model cars, planes, and boats. Radio waves are also used for radio frequency identification. This identification system involves tagging an object, animal, or person with a microchip that responds to specific radio frequencies. It can also be used to identify pets. Radio waves are also used for radar. Radar is an acronym for radio detection and ranging. It makes use of radio waves for detecting objects, weather forecasting, military surveillance, air traffic control, speed monitoring, and tracking satellites and debris. Radio waves are also used for global positioning system. It measures the time it takes a radio wave to travel from several satellites to the receiver, determining the distance to each satellite. Radio waves are also used for MRI, meaning magnetic resonance imaging, which uses short radio waves with a magnet to create an image. Radio waves are also used for radio transmission. Radio stations change sound to EM waves, and then your radio receiver changes the EM waves back to sound waves again. A radio picks up radio waves through an antenna and converts it to sound waves. Each radio station in an area broadcasts at a different frequency. The number on the radio dial tells the frequency. What are the classification of radio waves? We have the low frequency, the medium frequency, the high frequency, the very high frequency, and the ultra high frequency. For the low frequency, its frequency ranges from 3 times 10 to the power of 4 to 3 times 10 to the power of 5. Its application is for long-distance communication and navigation. For the medium frequency, the frequency ranges from 3 times 10 to the power of 5 to 3 times 10 to the power of 6. Its common application is for the AM band, or the amplitude modulation radio broadcasting. For high frequency band, its frequency ranges from 3 times 10 to the power of 6 to 3 times 10 to the power of 7. Its application is for shortwave broadcasts, tags for use in building access, public transportation, and electronic payment systems. The very high frequency band ranges from 3 times 10 to the power of 7 to 3 times 10 to the power of 8. Its common application is for the FM, or frequency modulation broadcasting, ground to aircraft, and aircraft to aircraft communication. The ultra high frequency ranges from 3 times 10 to the power of 8 to 3 times 10 to the power of 9, and its common application is for police radio communications, military aircraft and television transmissions, modern mobile phones, and global positioning systems. Now, let's talk about microwaves. Microwaves are the basis of almost all space communications. The microwaves region in the spectrum lies between 3 times 10 to the power of 8 Hz and 3 times 10 to the power of 11 Hz, with wavelengths ranging from 10 to the negative 3 meters to 10 to the negative 1 meters. James Clerk Maxwell was credited for discovering microwaves in 1864. Microwaves are sometimes considered as extremely high frequency radio waves but very short wavelength. Now, what are the uses of the microwaves? So, microwaves are used mainly for communications. They are mostly used for long-distance telephone calls before the introduction of optical fibers. Mobile phone uses a transmitter chip to produce microwaves. Now, microwaves are also used for food cooking. Food is cooked in a microwave oven by absorbing microwaves. Metallic objects reflect microwaves. This is the reason why metallic objects are not used in microwave ovens. Non-metallic objects such as glass and plastics can be used as containers for heating food in microwave ovens. Why? Because they allow microwaves to pass through and thus cook the food inside these containers. Microwave-safe containers are specially designed to resist radiation from microwaves. Microwaves are also using a magnetron. A magnetron is a transmitter that converts electrical energy into microwave radiation. Microwaves are also used for medical purposes. They are also utilized in medical fields, especially in monitoring cancer treatments. Now, let's move on to the next type of electromagnetic waves, that is, the infrared waves. Now, the infrared word literally means below red. Infrared radiations have lower frequencies than the red part of the visible lights. Infrared waves have wavelengths between that of microwaves and visible light in the electromagnetic spectrum. Infrared waves have frequencies which ranges from 3 times 10 to the power of 11 Hz to 4 times 10 to the power of 14 Hz, with wavelengths ranging from 7.5 times 10 to the negative 7 meter to 10 to the negative 3 meters. Infrared waves was discovered by Sir William Herschel in 1800. Now, this infrared radiation cannot be seen but can be felt as heat. So this heating effect is detected by temperature-sensitive nerve endings in the skin. How do infrared waves affect humans? If skin is exposed to too many high-energy infrared waves, it will become burnt. Now, infrared waves are also used in remote controls for television, burglar alarm systems, night vision cameras, and certain types of thermometers. How do infrared waves again affect humans? They also heal sports injuries. And this is also used for diagnosis and prognosis in areas like oncology, rheumatology, sports medicine, and orthopedics. This infrared waves also helps in monitoring the progress of therapy and rehabilitation. Now, what are the other sources of infrared waves? Other sources of infrared are the lamps, the infrared lamps. Then we also have the stoves, the flat irons that is used to straighten your hair. Then we also have the coal and oven toasters, and also the incubators, where babies born earlier than their expected date of birth are kept for a certain period of time. Then we also have the xenon lamp, the xenon arc lamp used in projectors and searchlights. We also have the tungsten filament lamp. The tungsten filament lamps emit infrared radiation and are used for general lighting and paint drying. Now, let's go to the visible light. The visible light enables us to see the physical world around us. It is also used in the process called photosynthesis. In this process, light energy from the sun is absorbed by plants and is converted into chemical energy, which is stored in the substance form called glucose. This is the simplest form of sugar or carbohydrate. Now, visible light is a small portion of this spectrum. This is the only part of this energy range that our eyes can detect. What we see is a rainbow of colors. Visible light is within the range of 8 times 10 to the 14 Hz with corresponding wavelengths of 4 times 10 to the negative 7 meters to 8 times 10 to the negative 7 meters. What happens when a light is allowed to pass through a prism? It undergoes the process called dispersion. And what is dispersion? Dispersion is the splitting of white light ray into a spectrum of colors. Like this. You try to take a look at how the white light ray is dispersed into the spectrum of colors. When light enters into a new medium, it bends. Each wavelength bends a different amount, allowing white light to separate into its various colors, namely the Roy G beam. What is the meaning of Roy G beam? It is an acronym for red, orange, yellow, green, blue, indigo, and violet. Now, what are the uses of the visible light? Visible light is used in laser. Okay, what is a laser? A laser is an acronym for light amplification by simulated emission of radiation. It is a device that emits light through a process of optical amplification with an increasing power. And another is that the laser is the intense source of visible light. Lasers used in light shows must be used safely because it is also dangerous. Some very powerful lasers can cut through materials such as metal. This will also be able to burn through living tissues. Now, these are the application of laser. We have here different fields of application and the function. So for military, this laser is used in marking targets. Let me use here a pointer. So for military, this laser is used in marking targets, measuring range and speed. In the industry, lasers are used for cutting and welding materials, compact disc and DVD players. Lasers are also used for laser printers, barcode scanners. In the field of machine, in the application for machine, lasers are used to remove cataract, for correcting vision, for skin treatment such as skin cancer, skin lesion, removal of tattoo, removal of unwanted hair and spots on the skin, and a lot more. There are also disadvantages of laser. Laser can cause severe burns in the surroundings and possible side effects in skin cancer treatment. That is due to greater pressure. Some cancer cells may be pushed deeper into the patient's internal body parts, which may lead to the cancer cells spreading out and multiplication. How does visible light affect humans? Very bright light can damage your eyes and may even make you blind. This is why you should not look at the sun through a telescope or any binoculars. So those are the low frequency electromagnetic waves. What are the electromagnetic waves that are considered as having high frequency? These are the following. We have the ultraviolet or UV rays, the X-rays, and the gamma rays. Now, let's talk about ultraviolet rays. Do you know why some newborn babies are exposed to early morning sunlight? Because newborn babies exposed to early morning sunlight absorbs only lower amount of UV radiation. And absorption of small doses of UV rays of the human body is important because it plays an important role in the production of vitamin D. And vitamin D helps in the production or absorption of calcium. However, overexposure leads to cancer and cataract. Now, ultraviolet rays has a frequency ranging from 8 times 10 to the 14 Hz to 10 to the power of 17 Hz and has a wavelength ranging from 6 times 10 to the power of negative 10 meters to 4 times 10 to the power of 7 meters. Ultraviolet radiation is discovered by Johann Wilhelm Ritter. What are the classification of UV rays? We have UVA, UVB, and UVC. UVA. UVA has a wavelength range of 350 nanometers to 400 nanometers. It has more penetration in the earth than UVB. It has the longest wavelength and lower energy, and due to its long wavelength, it can enter into the cornea of the eyes and reach the lens and retina. It accounts for 95% of solar UV reaching the Earth, and overexposure to this leads to cataract. Then, it can also be associated with the formation of an eye problem called macular degeneration. What are UVB rays? UVB rays has a wavelength range of 280 nanometers to 314 nanometers. Its wavelengths and energy are higher than UVA rays. In lower doses, UVB rays stimulates melanin. In higher doses, UVB rays can cause sunburn, skin discoloration, wrinkles, loss of skin elasticity, and other signs of premature aging of the skin. And it is filtered by the ozone in the atmosphere. Now, let's try to take a look at the UVC rays. UVC rays has a wavelength range of 60 nanometers to 279 nanometers. They are the most harmful to one's eyes and skin because they carry energy of great strength as compared to UVA and UVB. It is almost completely absorbed by the atmosphere and does not reach the Earth's surface. What are the ways to prevent effects of UV radiation? First is avoid sun exposure between 10 a.m. to 2 p.m. Another is wear protective materials such as sunglasses, light-colored clothing which can reflect some UV rays, and a white brim hat to protect eyes, face, and neck. Another is apply a broad spectrum for UVA and UVB protection with an SPF factor of 15 and above after every 2 hours. Now, let's try to take a look at X-rays. X-rays have frequencies ranging from 3 times 10 to the power of 16 to 3 times 10 to the power of 19 Hz. This has wavelengths ranging from 10 to the negative 12 nanometers to 10 to the negative 8 nanometers. These are emitted by machines used for medical diagnosis. X-rays are sometimes called Roentgen rays, named after their discoverer Wilhelm Roentgen, and are classified as soft or hard. When we say soft X-rays, these are X-rays which penetrate soft substances like flesh, bones, and others, while hard X-rays are more penetrating and are used mainly for industrial applications. X-rays are emitted by industrial machines used to measure tiny objects and detect flaws in products. In the environment, it may originate from a nuclear plant and from the radioactive substances. In the outer space, X-rays are also believed to be emitted during star formation and explosion. They carry energy which is strong enough to cause ionization of atoms and disruption of molecular bonds. Radiation can pass through many materials like our skin. However, denser materials like bones absorb these. That is why bones appear as a white image in the X-ray film, while the softer tissues appear as black areas. In the bones and teeth, X-rays are absorbed, and the light part of the X-ray image indicates a place where the X-ray was absorbed. What are the other uses of X-rays? X-rays are used in the luggage scanner, dental examinations, CT scan, and in the radiation therapy. What are the hazards of X-rays? Because of its ionizing property, it is one of the causes of the different forms of human cancer. And also, it can cause genetic damage or mutation leading to birth defects or diseases. Let's move on to gamma rays. What are gamma rays? Gamma rays are given off by radioactive materials like cobalt-60 and cesium-137. They are highly penetrating because of their very short wavelengths ranging from less than 10 to the negative 14 meters to 10 to the negative 10 meters. They have frequencies of at least 3 times 10 to the negative 19 Hz, and they are discovered by Paul Villard in 1900. What are the sources of gamma rays? Some of the sources are astronomical objects including the sun, clouds of interstellar matter, remnants of supernova. What are the uses of gamma rays? Gamma rays are used in industries to detect crack in metals. Then, it is also used to sterilize equipment in commercial product. They are also used in mining and refining chemicals and other industries to control levels, density, thickness, and other properties. They are also used to kill bacteria, insects, and other parasites that can cause foodborne diseases. They also help breed new seed variety with higher yields. They are also used to destroy cancer cells in a process called radiotherapy. Gamma rays are used in radiation treatment to kill cancer cells. They can be harmful if not used properly. Dense materials like lead at certain thickness can slow down its speed or even block it. Gamma rays can result from nuclear reactions taking place in objects such as pulsars, quasars, and black holes. Gamma rays are released spontaneously by certain nuclei of radioactive materials called radioactive decay. Gamma rays may also originate from human-made sources like X-rays. These rays stay in the environment for as long as their energy is used up. A person may absorb X-rays through direct exposure, external or internal. This may happen when an individual inhaled or ingests radioactive materials that are considered as gamma rays, like potassium-40, found in soil and water and in some foods. And what are some of the gamma ray emitter? We have here potassium-40, cobalt-60, cesium-137. How does gamma rays differ from X-rays? They differ in origin. Gamma rays are emitted by the nucleus of a radioactive nuclide or atom. X-rays are emitted by electrons that surrounds the nucleus. Now, how do ionizing waves affect humans? When we say ionizing waves have enough energy to ionize the atoms in materials. These waves can have a severe effect on living tissue by killing cells or damaging DNA. What are the ionizing waves? First, we have the ultraviolet rays. These are absorbed by the body. Skin tissues can be ionized and damaged by the shortest wavelength ultraviolet radiation, causing skin cancer. Another is X-rays, which pass through soft body tissue such as skin and muscle without being absorbed. Denser tissue such as bone absorb some X-rays and can be ionized. Gamma rays can pass through the body, but very high energy waves can ionize atoms in living tissues. So, let's try to recall what are the high frequency EM waves. These are the ultraviolet rays, the X-rays, and the gamma rays.